Hi, welcome back. Today we'll be writing code to set up our Sagemaker instances and endpoints and also implement the inference pipeline. But before that, first let's understand how modern languages process multilingual queries. Language processing in AI systems follows a very specific flow. Think of it like an international post office handling mail in different languages. There are three critical stages in language processing. First is language detection and routing. Just like a post office needs to identify which country a letter is going to, our system must first identify the language. But there's a key difference in AI systems. We are not just looking at the address, which are the obvious language markers, but at the entire content, which is the semantic meaning behind it. Second is the context management. Modern language models don't just translate word by word, they maintain context across sentences. Think of it like having a conversation where you remember what was said earlier. Our system needs to manage this context while switching between languages and domains. And the third is inference optimization. When processing queries, we need to balance between two competing needs. First is the speed. Users always expect quick responses. And the second is accuracy. Responses must be accurate and contextually appropriate. This is like choosing between express and regular mail delivery. Now let's understand how data flows through our system. The input text that is sent by the customer enters through our API, and the language detection runs first, which is very lightweight. Now the appropriate adapter gets loaded and the full inference runs with loaded adapter. Finally, the response gets formatted and returned back. Now that we understand these concepts, let's implement our Sagemaker setup configuration. Now we'll look into our Sagemaker setup file, which is responsible for deploying our multilingual support system on AWS Sagemaker. We first have to install the necessary SDKs like Boto3 and Python, which interact with AWS services to create endpoints or managing resources. We also import our configurations and logger that we set up earlier. Now we'll look into our main multilingual support deployment class. When our deployment starts, the initialization method sets up all necessary connections to AWS. The Sagemaker session creates our main connection to Sagemaker. We get our account ID using the security token service STS. This helps identify our AWS account. And then we create two Sagemaker clients, one for managing deployments, which is the Sagemaker client, and another for running our models, which is the runtime client. Finally, we get our IAM role, which gives our deployment the necessary permissions. Okay, now that we have initialized our Sagemaker resources, let's dive into setting up our container. This method gets the location of our container image. A container is like a package that includes everything needed to run our model. We're using DJL DeepSpeed here, which is a specialized container for running large language models. It includes optimizations that make our model run faster and use less memory. The container version, which we configured in the configuration file, includes support for LORA adapters and efficient model serving. Okay, now let's move on to creating our model. The create model method sets up our model in Sagemaker. We first get our container URI, then we set up environment variables. The Hugging Face model ID tells Sagemaker which model to download from Hugging Face. The option enables LORA, which is set to true, activates LORA adapter support. The maximum LORA rank and maximum CPU LORA control how our adapters work. And once the environment variables have been defined again, the model is created. The Sagemaker deployment process happens in three key stages, all managed within the Sagemaker setup file. First, the create model method sets up our model configuration. Even though we defined environment variables in configuration file, we need to pass them here because this is where we actually tell Sagemaker how to set up our container. We combine our base model settings with LORA specific configurations. Next, create endpoint config method defines how Sagemaker should deploy our model. The key settings here are container startup health check timeout in seconds, which is set to 600, gives our container 10 minutes to start. It is needed because loading LORA adapters takes time. The model data download timeout in seconds is set to 900, which allows approximately 15 minutes to download model files. The initial instance count is set to 1, which means it will start with just one instance, and the variant name set to all traffic routes all requests to this deployment. Finally, the create endpoint method launches our endpoint and waits for it to be ready. The waiter here is very important because it checks every 30 seconds up to 60 times whether our endpoint is ready. This is important because deploying large language models with LORA adapters can take several minutes, and in the deploy method, we start the deployment process for the model and the endpoint. Just to be sure, we are verifying that the AWS setup and permissions are set right. And at last, if something fails during this process, our cleanup method ensures we don't leave any hanging resources that could incur charges. It systematically removes the endpoint configuration, and the model configuration. Now let's look into the inference handler file. This processes customer queries and directs them to the appropriate language and domain adapters. This code demonstrates how we detect languages and support categories in customer messages. Starting with our imports at the top of the file, from our own module, we import LORA adapter manager, which manages our LORA adapters, and setup logger for tracking system operations. Now we initialize the customer support inference class. This class serves as our main query processor. In its initialization, we create an instance of LORA adapter manager. This gives us access to our language models and their specialized adapters. Now, for our language and domain detection method, we're using a simplified detection system based on keyword matching. The language markers dictionary contains common words for each supported language. For Spanish, we look for words like hola, gracias, and por favor. Similarly, French and Russian have their respective common phrases. Domain detection follows the same pattern. They help identify what type of support the customer needs by analyzing the query content for specific indicators. Technical support queries often contain words like error, broken, or not working. Billing-related queries mention payment, charge, or invoice. Product support queries typically include terms like features or specifications. Each domain has its specialized adapter trained on relevant support conversations. We search for domain-specific keywords in the query, and if nothing is found, we default it to technical support. This ensures that every query has both a language and domain assigned to it, even if we can't definitely determine them. Next, when detecting the language, we first convert the query to lowercase to ensure consistent matching. The detection loop checks if any language marker appears in the query. As soon as we find a match, we set the detected language and exit the loop. Let's now look into our main query processing method, which serves as the entry point for our customer messages. When a query arrives, it first passes through our language and domain detection system. And once we detect that, we use the adapter manager to get a response. The invoke model method receives 3 parameters here. One is the customer's message. Then it receives the detected language, and at last it receives the support domain. The method returns a comprehensive response dictionary containing the query status, detected language, and domain. It also returns the original query for reference and the generated response. If any errors occur during processing, we catch them in the try except block, log the error details, and return an error status with the error message. In a production environment, you would replace this simplified detection system with more sophisticated language detection models and domain classification systems. But for our learning purposes, this implementation demonstrates the core concepts of our multilingual customer support system. Now that wraps up for our inference pipeline implementation. In the next video, we'll add comprehensive testing and monitoring to make this production ready. If you're following along, try modifying the language adapters to support additional languages. Share your implementations in the comments below. Next up, we'll look at testing and optimization strategy.